Hi class, today we are going to learn about Form 4 KSSM Chemistry, Chapter 6.5, Concentration of Aqueous Solution. Concentration of aqueous solution. Learning Standard 6.5.1 State the meaning of concentration of solutions. 6.5.2 Solve numerical problems involving concentration of solutions. Concentration of a solution is a measurement that shows the quantity of solute dissolved in a unit volume of solution. So for the concentration, we have concentration in the unit of gram per dm cube. This indicates that the amount of the solute or mass of solute dissolved in 1 dm cube of solution. So this concentration is in unit gram per dm cube. So the formula is mass over volume, and the volume is in the unit of dm cube. Next, we will have another concentration called molarity. Molarity, in which the unit is in mole per dm cube. Mole per dm cube. So we call this concentration as molarity. It is the number of moles of the solute dissolved in 1 dm cube of solution. So this concentration in the mole per dm cube unit, it is called as molarity. So the formula of molarity is equal to number of mole of the solute over volume. And the volume also in the unit of dm cube. Here is the relationship between the concentration and molarity. Relationship between concentration and molarity. So we have concentration in gram per dm cube, and we have another concentration in the unit of mole per dm cube, and that concentration we call it as molarity. So when we have concentration in gram per dm cube, we want to change to molarity in mole per dm cube. So we need to divide by molar mass. If you want to change from concentration to molarity, you need to divide by molar mass. Divide the concentration by molar mass. And if you want to change molarity to concentration, then you need to times molar mass. Molarity times molar mass, and you will get the concentration in unit of gram per dm cube. And another information is the unit for molarity is mole per dm cube or in molar, M, in M, capital letter M. Okay, now it's the example 1, concentration. So, a student dissolved 40 grams of solid copper 2 sulfate in water to make a 20 dm cube of the solution. What is the concentration of the solution in gram per dm cube? A student dissolves 40 grams of solid copper 2 sulfate in water to make a 20 dm cube of solution. What is the concentration of the solution in gram per dm cube? So now look at this question. What is the information you have? First is 40 grams of solid copper 2 sulfate. You need to dissolve it in water to make a 20 dm³ of solution. So now the question is, you need to find the concentration of the solution in gram per dm³. So now, information you have is mass of the solid copper 2 sulfate with the formula CuSO4 is equal to 40 gram. 40 gram. And the volume of the solution is equal to 20 dm³. Next, concentration of the copper 2 sulfate solution. Mass of the copper 2 sulfate divided by volume of the solution. So you need to remember the formula, the concentration in gram per dm³. Use the mass of the solute divide the volume of the solution in unit of dm³. Mass of copper 2 sulfate you have is 40 gram. Volume of the solution is 20 dm³. So 40 divided by 20. So can you take out your calculator and a blank paper to calculate? So what is the answer for this concentration of the copper 2 sulfate solution? Take out your calculator to calculate it. Alright, very good. The answer is 2.0 gram per dm³. 2.0 gram per dm³. So this is the concentration of the solution in gram per dm³. Next, example 2. It is about molarity. Molarity. 28 grams of potassium hydroxide is dissolved in the water to make a 200 cm³ of the solution. Calculate the molarity of potassium hydroxide solution obtained. So, the relative atomic mass for the hydrogen is 1, oxygen 16, potassium 39. So what is the information you have? You need to practice it and write it down. So mass of the potassium hydroxide is KOH. You need to know that the potassium hydroxide, the formula is KOH. It is 28 grams. And the volume of the solution is 200 cm³. So now, still you remember the formula for molarity? Formula for molarity. What is the unit for molarity? Still you remember? Can you tell me what is the unit for molarity? Okay, good job. Molarity, the unit is mole per dm³. Mole per dm³. So, means that the formula for molarity, it is number of mole of the solute divided by the volume. Divide by the volume. So now, you need to find the number of mole of the potassium hydroxide. But you are given the mass of the potassium hydroxide only. So now, how you can find the number of mole of the potassium hydroxide? Still you remember, this is in the previous chapter. So, first step, you need to find the number of mole of potassium hydroxide, KOH. So number of mole of potassium hydroxide is equal to mass over molar mass. Mass over molar mass. So now, try to calculate the number of moles of potassium hydroxide. Take out your calculator and find the answer. The mass of potassium hydroxide is 28. Molar mass of the potassium hydroxide, you need to add in all the molar mass. And remember, the molar mass, unit of molar mass is in gram per mole. 28 gram divided by, bracket, 39 K. Oxygen is 16 and hydrogen is 1. So, you will get the final answer is 0.5 mole. Can you get the correct answer with me? Yes, very good. So now, we have number of mole of the potassium hydroxide. It is equal to 0.5 mole. And we have also the volume. So now, what we can find next? Yes, very good. Molarity. Next, we need to find the molarity. So, molarity of potassium hydroxide is equal to number of mole divided by volume. But remember, the volume must be in unit of dm³. So, number of mole is 0.5 mole divided by, you are given the volume is 200 cm³. So, you need to divide by 1000 to convert it into dm³. 200 cm³ divided by 1000 will change into the unit of dm³. So, remember, 1 dm³ is equal to 1000 cm³. If you have the unit is in cm³, you need to change to dm³. Remember, you need to divide by 1000. So 200 cm³ divided by 1000 is equal to 0.2 dm³. So now, try to calculate. Can you get the correct answer? Okay, very good. The final answer is equal to 2.5 mole per dm³. 2.5 mole per dm³. Good job if you can get the same answer with me. Alright, next. Example 3. Conversion of the units of concentration. A potassium chloride solution has a concentration of 14.9 gram per dm³. What is the molarity of this solution in mole per dm³? So now we need to convert the concentration into molarity. Concentration into molarity. Still you remember the relationship between the concentration and molarity? Alright, so this is the relationship between the concentration and molarity. If we are given the concentration, we need to change it into the molarity. We need to divide the concentration by molar mass. So, we are given the concentration of potassium chloride, KCl. Concentration of potassium chloride, KCl, is equal to 14.9 gram per dm³. So now we need to find the molarity. If you want to find the molarity, you need to use this formula. Concentration of the KCl divided by molar mass of KCl. So you will have 14.9 gram per dm cube. Now you need to divide the molar mass of KCl, potassium chloride. So it is 39 plus 35.5. So you will get the answer is 0.2 mole per dm cube. Alright, good job. Next, example 4. Conversion of units of concentration. The concentration of barium hydroxide solution in a reagent bottle is 0.4 mole per dm cube. What is the concentration of this solution in gram per dm cube, given that the relative atomic mass of hydrogen is 1, oxygen is 16, where barium is 137. So now try to answer these questions. Now you are given the concentration in molarity. So you need to find concentration. Molarity change to concentration, you need to times the molar mass. So molarity given for the barium hydroxide is 0.4 mole per dm cube. You must remember that the formula for the barium hydroxide is Ba bracket OH2. Ba bracket OH2. So now, concentration of barium hydroxide is equal to molarity times molar mass. Molarity times molar mass. So try to calculate it. Molarity of the barium hydroxide is 0.4. Molar mass is adding all the relative atomic mass together. So you will have 0.4 mole per dm cube times. Okay, here is the molar mass. Ba is 137 plus, here we have bracket 2. So means that you have double of oxygen and hydrogen. So put a 2 in front of the bracket. Inside it, oxygen is 16. Hydrogen is 1. So adding all together and times the molarity, you will get the final answer is 68.4 gram per dm cube. Always remember to write the unit. Concentration of barium hydroxide, Ba bracket OH2, is equal to 68.4 gram per dm cube. Can you get the same answer with me? If you can get the correct answer, congrats. Very good. Good job. So this is the relationship between the concentration and the molarity. Always remember, concentration change to molarity divided by molar mass. Molarity change to concentration times molar mass. Now we are going to look at the relationship between the number of moles of the solute with the molarity and volume of a solution. Relationship between the number of moles of solute with the molarity and volume of a solution. So, molarity of a solution, the unit is mole per dm cube, but we also can write it in capital letter M. So, molarity of a solution is equal to number of mole of the solute divided by the volume of the solution in dm cube. So, now, can you know that what is the formula for the number of mole of the solute? So, if you base on the molarity, the formula of molarity, if you want to find the number of mole of the solute, then you need to divide the molarity by the volume of the solution. And finally, you can get the number of mole of the solute is equal to Now, we are going to look at the relationship between the number of moles of solute with the molarity and volume of a solution. Relationship between the number of moles of solute with the molarity and volume of a solution. Molarity of a solution. Still you remember molarity of the solution? What is its formula? Correct. The formula of molarity of a solution is equal to number of mole of solute divided by volume. Remember, molarity is in mole per dm cube, but we can also write it in the capital letter M. This one also represents the mole per dm cube. Number of mole is unit in mole. Volume of the solution, the unit is in dm cube. Always remember this. So, if you are given the formula like this, then do you know that what is the formula of number of mole of solute? Can you tell me what is the formula for number of mole? If you want to find the number of mole, then what is the formula you need to use? Okay, very good. If you want to find the number of mole of the solute, you need to use the formula molarity times volume. Molarity times volume, because this volume you move to the left hand side. So you will get the formula is number of mole of the solute is equal to molarity times the volume, and n equal to number of mole of the solute. Capital letter M is equal to the molarity. V equal to the volume of solution. So it is in unit of dm cube. Volume is in unit of dm cube with the formula N equal to mv. N equal to mv. But we have also another formula. N equal to mv over 1000. N equal to mv over 1000. So, do you know that what is the unit for this volume in this formula? Can you answer me? What is the unit for the volume in this formula? N equal to mv over 1000. Good job! The volume, the unit of the volume in this formula is in cm cube because V over 1000 dm cube over 1000 will become cm cube. So, if you use this formula, remember that the volume is in the unit of cm cube, N equal to mv over 1000. But if you use the formula N equal to mv, remember that the V is in the unit of dm cube. So next, example 5. Relationship between molarity, volume, and number of mole. Relationship between molarity, volume, and number of mole. Okay, the question is, calculate the mass of the calcium hydroxide in 50 cm cube of 0.01 mole per dm cube of calcium hydroxide solution. Given that relative atomic mass is equal to hydrogen is equal to 1, oxygen is 16, calcium is 40. So try to answer these questions. What is the information you have? Information you have is molarity. You need to remember mole per dm cube. This one is the unit for molarity. So you will have molarity of calcium hydroxide is 0.01. Volume, you also will have it, is 50 cm cube. And the question asks you to find the mass of calcium hydroxide. And you see, the question, usually it will not give you the formula. So you need to know that calcium hydroxide, the formula for calcium hydroxide is Ca bracket OH2. Ca bracket OH2. So now, what you need to find first? Given the molarity is 0.01, volume is 50. So first step, what you need to find first? Can you tell me? Okay, so you see the volume is in cm cube and you are given the molarity. So you can find the number of mole of the calcium hydroxide first. So you can use this formula. Alright, try to find it first. See whether your answer is same with me or not. First step. Number of moles of calcium hydroxide is equal to mv over 1000. So try to calculate. Alright, so 0.01 mole per dm cube times 50 over 1000. So now you will get that the answer is equal to 0.0005 mole. So the answer is 0.0005. Can you get the same answer with me? Okay, good job. And can you see that we have the volume in cm cube? So when we divide by 1000, the unit will change from cm cube to dm cube. Cm cube to dm cube. So we will have dm cube here now. And when we cancel out, we will get the unit is in mole. Unit is in mole. So this is the number of mole of the calcium hydroxide, mv over 1000. So next, what we need to find now, we need to find mass of calcium hydroxide. So now you already found that the number of mole of the calcium hydroxide is equal to 0.0005 mole. So, second step. Always remember mass is equal to number of mole times molar mass. So, molar mass of calcium hydroxide is 40 plus 2 bracket 16 is oxygen, H is hydrogen, 1 is for hydrogen. So remember here got bracket 2, double. So you need to times 2 in front of O and H. Okay, try to calculate it. 0.0005 times the molar mass of calcium hydroxide. So adding all the molar mass together, the molar mass of calcium hydroxide is equal to 74. So when you do the calculation, please, you need to be careful. So the final answer is equal to 0.037 gram. Mass of calcium hydroxide is 0.037 gram. Good job if you can get the correct answer. Next, example 6. Relationship between molarity, volume, and number of mole. A 0.5 mole per dm cube lithium hydroxide solution contains 6.0 gram lithium hydroxide. Calculate the volume of this solution. Given that the relative atomic mass of hydrogen is 1, oxygen is 16, lithium is 7. So, what is this? Can you answer me? What is this 0.5 mole per dm cube? Okay, good job. It is molarity. Molarity of lithium hydroxide, 0.5 mole per dm cube. So you write down the information you have. You have molarity is 0.5 mole per dm cube. Mass of the lithium hydroxide is 6.0 gram. So you need to find the volume of the solution. So, what you need to find first? Always remember the formula. Number of mole is equal to mv over 1000, or number of mole is equal to mv. This v is in cm cube. N equal to mv. The volume here is unit is in dm cube. So you are given the molarity 0.5, mass 6.0, volume is don't know, you need to find it. So what you need to find first, so that you can find the volume also. So first step, always remember you can find the number of moles first. So can you tell me what is the formula here to find the number of mole? Given that the mass of lithium hydroxide is 6.0 gram. Okay, good job. Number of mole is equal to mass over molar mass. So mass of the lithium hydroxide is 6.0 gram. And you already know that here is the relative atomic mass. So from here, you can get the molar mass of the lithium hydroxide. So 6 over molar mass of lithium hydroxide. 7 is relative atomic mass for lithium. 16 is RAM of oxygen. 1 is RAM for hydrogen. So try to calculate it. What is the number of moles of lithium hydroxide? Okay, very good. The answer, the number of moles of the lithium hydroxide is equal to 0.25 mole. 0.25 mole. Next, you have two methods to find it. See whether you use which formula. If you use this formula, N equal to mv, always remember that the volume is in the unit of dm cube. Okay, let's look. Second step, find the volume. So given this formula, can you tell me how you find the volume? So the volume is equal to what? The formula of volume, can you tell me? Very good. You move the molarity to the another side. So you will get the formula of the volume of the solution is equal to number of mole over molarity. Number of mole over molarity. So number of mole you have is 0.25 mole. And molarity you have is 0.5 mole per dm cube. So try to calculate it. What is the volume? You get 0.25 divided by 0.5. Can you get the answer? Okay, good job. The answer is 0.5 dm cube. 0.5 dm cube. And now, the unit is in dm cube. The unit is in dm cube. So, if the question asks you to find the volume in cm cube, if the question asks you to find the volume in cm cube, so now what you need to do to change the dm cube to cm cube? Still you remember it? How you change the dm cube to cm cube if the question asks you to find the volume in cm cube? Can you tell me? Alright, good job. So 0.5 times 1000. 0.5 dm cubed times 1000. You will get the unit, the volume in the unit of cm cubed. So here is your answer. Volume of the solution is equal to 500 cm cubed. And now, if you use the another formula, N equal to mv over 1000, you just directly change it from this formula to get the formula of volume. So volume of the solution is equal to number of mole times 1000 over molarity. Number of mole times 1000 over molarity. So you will get number of mole is 0.25 and times 1000 over 0.5 mole per dm cube. So final answer you get is directly in the unit of cm cube. If you use this formula mv over 1000, the unit is in cm cube. Okay, so next. Example 7. Relationship between molarity, volume, and number of moles. Calculate the number of moles of hydrogen ions in 200 cm cube of 0.5 mole per dm cube of the sulfuric acid. Calculate the number of moles of hydrogen ions in 200 cm cube of 0.4 mole per dm cube sulfuric acid. See this question, you need to find the number of mole of hydrogen ions. Hydrogen ions. So, you have the molarity of the sulfuric acid is 0.4 mole per dm cube. Volume of the sulfuric acid is 200 cm cube. And the question asks you for number of mole of hydrogen ions in the solution. So, first step, what you need to find? Can you tell me what you can find first from the information you have here? Molarity, volume. So, you can find the number of mole of the sulfuric acid first. Very good. So, we use this formula. Why? Because the unit of the volume is in cm cube. So, we can use the formula N equal to mv over 1000. N equal to mv over 1000. So first step, find the number of mole of sulfuric acid. Sulfuric acid, H2SO4. It is very important that you need to know the formula for the substance. For any compound, you need to remember the formula. Okay, number of moles of sulfuric acid is equal to mv over 1000. So, molarity is 0.4. Volume is 200 and divide by 1000. You will get the answer for the number of mole of sulfuric acid is 0.08 mole. Is this the final answer for the number of mole of hydrogen ions? Good. No, it is not the final answer. This is only the number of mole of sulfuric acid only. But you need to find the number of mole of the hydrogen ions in sulfuric acid. So next, what you need to find first. Before you find the number of mole of the hydrogen ions, what you need to write first? Can you get it? Okay, good job. Second step, you need to write the ionization equation or dissociation equation of sulfuric acid. So, can you write down the sulfuric acid ionization equation for sulfuric acid? Can you write it correctly? Okay, good job. So this is the dissociation equation of sulfuric acid. So you see, one molecule of sulfuric acid will produce two hydrogen ions. So sulfuric acid is diprotic acid. This one you learned already in the previous subtopic. So now, based on the ionization equation, 1 mole of the sulfuric acid produces 2 mole of the hydrogen ions. 1 mole of the sulfuric acid produces 2 moles of the hydrogen ions. So, you already found that the number of mole of the sulfuric acid is 0.08 mole. So now you need to find what is the number of mole for the hydrogen ions. So just based on this, so you can find it, the number of mole of the hydrogen ions in the solution. So now take out your calculator, press the calculator to find the answer. Can you get the correct answer? Let's check it later. Okay, so number of mole of the hydrogen ion is equal to 0.08 mole times 2. So you will get the number of mole of the hydrogen ions in the solution is 0.16 mole. Can you get the correct answer? Okay, very good. Good job. Okay, so we already finished discussing all the examples. So always remember, concentration is in the unit of gram per dm cube. Then the formula will be mass in unit of gram over volume in unit of dm cube. If the concentration is in the unit of mole per dm cube, then the concentration we can call it as molarity. So formula for molarity is equal to number of mole over volume. The volume also in the unit of dm cube. This is the relationship between the concentration and molarity. Concentration in the unit of gram per dm cube. Want to change to molarity in mole per dm cube, you need to divide by molar mass. And molarity in mole per dm cube, you need to change back to the concentration in gram per dm cube. You need to times molar mass. Always remember this relationship between the gram per dm cube and the mole per dm cube. And this relationship between the number of mole, molarity, and the volume. So, this one is what you need to remember. Number of mole is equal to mv. So, the v is in the unit of dm cube. And another one, number of mole equal to mv over 1000. This volume is unit in the cm cube. That's all for today. Thank you.